Everyone. So tonight we're going to take a look at your Chapter 3 test review and make sure that you know everything you need to know about all these functions and transformations, composites, inverses, all that kind of stuff. So looking at this first one, it's talking about the absolute value function, y equals the absolute value of x, and it asked me all these questions. Probably before I start, I'd love to have a graph of this thing to look at, okay? And I was about to just sketch one, but I noticed that down here in question F, it says graph the parent function and the new function. So let's go ahead and just graph the parent function now so we have it to refer to while we're answering the other questions. So absolute value of x was really going to look like the line y equals x. It's going to go straight up at a perfect diagonal there. But then the other side is going to go the other direction. Let's see, so we'll come down like this. Okay. So there's my absolute value function. By the way, quick time to show you this. I don't know that you would need this necessarily, but if you wanted to graph absolute value in your calculator, I wanted you to know how to do it. So when you look at your calculator in the math menu, under number, should be, I think, the very first option. Yep, ABS, that's absolute value. So you could type in absolute value of x and take a look at it on a graph. Okay, if you needed to, but my hope is that you just know what that picture looks like anyway. Okay, so equations for the asymptotes. Well, the question is, are there asymptotes here? And this doesn't do that, where it skims along a line at all. There are no asymptotes in the absolute value function. Just be careful. Some people like to say, like, oh, I could draw a line down here, and since the graph never touches that line, that's an asymptote. Remember, asymptote's not just a line that a graph doesn't touch, it's a line that it approaches infinitely, gets infinitely close to this line. So nothing down here would work. There are no asymptotes here. Okay, line of symmetry, just like our friend the parabola, line of symmetry goes straight down the middle here. Okay, and equation for that vertical line would be x equals 0. All right, domain and range. Well, domain, this does go forever left and right. Okay, so I would say domain is all real numbers. The range, I don't hit any negative y values down here. It's everything from 0 up will have a y value associated with it. So I would say all real numbers greater than or equal to 0. Then it says, give the new equation if the graph is shifted 2 to the left and 1 unit down. And then it does point out, write the rule first. And I'll be honest, I probably would have written the rule first, whether it said that or not. Okay, that's just a good habit to get into. So the rule for this is going to be a translation, right? So it's going to look something like x, y, I'm using a t for translation, turns into, and again, normally we only care about this part of the rule. That would be fine with me too. If we want to go 2 to the left, that would be x minus 2, and 1 down would be y minus 1. When I go to put that into the equation, remember that first of all, anything that's going with x needs to go right with the x, meaning inside the brackets there. And then we would also want to make sure we do the opposites of everything. Okay, so where I see subtraction, I'm going to put addition into the problem. So my new equation would look like this. Y plus 1 equals absolute value of x plus 2. And then the only other thing I might do, I would be perfectly happy with this answer. Okay, you'd get full credit for this on a test. But when we get to ones where we want to be able to put them in our calculator to graph, we're going to want that y by itself. So when I write my final answer, I'm going to write it as y equals absolute value of x plus 2 with a minus 1 on the outside. I just took that plus 1 and moved it over here. Okay. So give the equation for the new asymptote. Well, there are still none. Okay. Shifting it over and down did not make there suddenly become an asymptote. New line of symmetry. So this orange line that we had in equation of x equals 0, that's going to shift according to this rule. So now we're going to have a line of symmetry at x equals negative 2. New domain and range. So I guess, and I skipped over this, I should have done this. I needed to graph that new function, right? I graphed the parent function. I never graphed the new one. So if we shifted 2 to the left and 1 down, that should be with a vertex starting here. Okay, so I went 2 to the left and 1 down, and then I'm still going to follow that same path here. Now, if you wanted some exact coordinates to be able to graph this thing, you could take some coordinates from the original graph. So say, for example, the coordinate 2, 2, or 5, 5, or let's see, -3, 3. You could take points like that and apply this rule to them. So you can move the individual points. I sort of did that with the vertex of this thing. I took this point and I said, all right, I'm shifting 2 to the left and 1 down, and then redrawing it here. That might help you get it in the right spot. Okay. We could also put this new function in our calculator, especially since we solved it for y. So I could now put the absolute value of x plus 2, close my parentheses with a -1 at the end, and graph it, and I should see that same picture that I have here. Okay. Okay, so now let's go back to the question of domain and range. The new domain here, domain's not going to change because it was all real numbers to begin with. When you have an infinite number of numbers to work with, shifting left or right really isn't going to change anything. So my domain is still all reals. My range, though, because this dropped down by 1, I can now say my range is shifted down to be all real numbers greater than or equal to -1. So again, I could kind of just think of it as my range is shifting according to this rule, right? I'm subtracting 1 from everything. Okay? And I think that's it for that question. But I think the point we're trying to drive home here is that all of these characteristics, domain, range, asymptotes, lines of symmetry, they're all going to shift according to that rule. So that's why it's helpful to write that rule out ahead of time. Okay, so let's try another one. And does this one eventually ask me to graph? Let's see. It sure does. I'm a little annoyed that I have to flip pages here. Sorry about that. But so I'm going to go ahead and graph 1 over x. Okay, on the, let's see, back here on part F, graph the parent function and the new function. And let's see, I'm going to get a couple of specific points on here just so I can make sure our picture looks nice. So with the function y equals 1 over x, if I plug in a 1, I'm going to get a 1 back out because 1 over 1 is 1. I plug in a 2, I'm going to get a 0.5 or a 1/2. If I plug in a 1/3, let's say, I'm going to get a 3 because 1 over 1/3 would be 3. Let me just do one more. If I plug in a 5, I'm going to get 1/5. So points-wise, I know I have 1, 1. I have 2 and 0.5. Jumping down here, I have 5 and 1/5, which I'm kind of expecting because I know I have an asymptote there. And then I have 1/3, 3. So this is going to be way up here. Okay, so this is going to kind of look like this. And then the thing is with this, if I plug in negative x values, I'm going to get all the same answers except with negatives on the y's. So if I plug in -1, I'm going to get -1. -2 becomes -0.5, and so on. Okay. So -1, -1 would be here. -2, -0.5 would be here. -5, -1/5 would be here. And -1/3, -3 would be about here. So there's my other curve. Okay. So there's my hyperbola. Okay, I could have done that with my calculator as well, looking at the table. But now I'm going to refer to that as I do these other things. So give the equations of the asymptotes. So looking at this graph, the hyperbola always has asymptotes at the x and y axis. So here's an asymptote, here's an asymptote. And the equations for those things would be x equals 0 and y equals 0. Okay, for asymptotes. So back here, my equations are x equals 0, y equals 0. Okay, lines of symmetry. is that next question. So let's look at that on here. And actually, I might dig for a different color. So that doesn't blend in with the asymptote. Sorry, I'm having a small collapse over here. Okay, so lines of symmetry on a hyperbola is kind of an interesting question. Lines of symmetry are actually the diagonal lines, like y equals x is a line of symmetry. And then also y equals negative x is a line of symmetry. Okay, if you picture folding that hyperbola in half diagonally, if I fold along this line, each branch is going to kind of be symmetric to itself. It's going to fold right here. If I fold along this line, this whole branch is going to flip over on top of this branch. Okay, getting a little smudged there. So back here when it wants equations for lines of symmetry, I would say y equals x and y equals negative x. I know for sure that's one you're going to want to know for your test. Okay, probably the other stuff in this question too, but I remember that in particular. Okay, so domain and range, and I'm going to run into trouble when I keep trying to flip this here. Hold on, there we go. So looking at your x values here on this graph, okay, my x values go forever to the right and forever to the left. So that makes me want to say all real numbers. The only exception is this gap in the middle where I've got that orange line drawn in, okay? I can't let x equal 0. I've got an asymptote there. So for my domain, I'm going to say all real numbers except 0. That also works for your range because your y's go up forever and they go down forever. They just don't hit this one number in the middle, which is 0. So domain and range are both all reals except 0. All reals except 0. Okay, new equation if the graph is horizontally stretched by 2, vertically shrunk by 1/2. And again, I'm going to write the rule first. This is going to be a size change. I'm still running low on the paper. Not working for me anymore. There we go. Okay, so horizontally stretched by 2, this is going to look like a 2x. And then vertically shrinks, I think they're trying to say like y over 2, or you could think of it as 1/2 y. Okay, so in my equation, y equals 1 over x. Here's my original function. I want to multiply the y by 2, and I want to divide the x by 2. Okay, so again, opposite of what you're seeing here. All right, so really this equation would look okay. 2y equals 1 over x over 2, which quite honestly, this is a little gross to me. Okay, but it would work for our purposes right now. If you did want to move this 2 to the other side, gosh, I really wouldn't want to see you like divide this whole thing by 2 because that would be really ugly. But I guess we could get away with something like this. Y equals 1/2 times 1 over x over 2. So I would be perfectly fine with that answer. I do want to show you something real quick here. So ultimately here, when I do 1 over x over 2, anytime you do 1 over something, that's just going to turn into a reciprocal. So 1 over x over 2 is really just going to become 2 over x. Okay? And then when I apply that 1/2 to it, this 2 and this 2 are going to cancel each other out. And this is going to just turn back into y equals 1 over x. Now, for the purposes of our test and what we've done so far, I've always had you just write it the ugly way because I want to see that you're putting those numbers into the equation. But if you did simplify it back down, I want you to see that it just turns back into itself. And so what's really happening here is if you stretch it horizontally but then shrink it vertically, it's going to just go back to where it started. Okay, so yeah, that's all there really is to this one. But if you had an answer that looks something like this terribleness, that's okay with me. Okay, and then graph the parent function and the new function. So what we actually just found was that that it would go back right to where it was before. So let me show you what I mean by that. If this was my XY table, and actually let's go back to the non-negative version of this. So let's go back to when we had 1, 1, 2.5, 1/3 and 3, and 5 and 1/5. Okay, let's go back to that. According to my rule, and let me just make sure I've got this right. According to my rule, I want to double all the x's and divide all the y's by 2. So like as an example, I would double this and make it a 2, and then I would divide this in half and make it a 0.5. Well, look at that. This right here is right there, okay? This was already on my function. And so that's what's really happening is the individual points are shifting around, but they're landing back on the original function, okay? So that's why this doesn't, ultimately, it doesn't change the graph at all to do that horizontal stretch and vertical shrink, okay? So your graph is just going to stay exactly the same. So that's why these next couple questions are kind of lame, because the new asymptotes are going to be right where the old asymptotes were. The new lines of symmetry are going to be right where the old ones were. So y equals x, y equals negative x. And my domain and range are going to stay the same too. Domain is all reals except 0. Range is all reals except 0. Okay. Now, let's suppose that something more dramatic happened here. Let's suppose we did something that actually made a difference. Okay. Your lines of symmetry would change according to that rule. So if you were multiplying your x's by 3, this would become y equals x over 3, okay? If you were shifting to the left or to the right, these asymptotes would shift with them. So whatever your new rule was. Now, these asymptotes aren't going to shift under a scale change because multiplying by 0 isn't going to make a difference. But if we were doing like a +5 or a -2, these would shift with it, okay? Same thing with the lines of symmetry. Okay, same thing with the domain and range. And again, domain and range is not going to change under a scale change, okay, because you're just multiplying. But if I was like shifting to the left or right, the x one would change. This would become all real numbers except whatever your new number was. Or if you were shifting up or down, this number would change. Okay, maybe we'll see that in the next question. But that one was kind of a quirky one because it came back right to where it was to begin with. So. Okay, let's look at number 3. Number 3, y equals 1 over x squared. And again, I'm going to jump down here and draw the graph first. I don't think I'll waste your time with the table this time. I think I'm just going to sketch it for you. So 1 over x squared looks like a hyperbola, but it's side by side. Okay. So there's my parent function. Asymptotes on this one are the same as the asymptotes on the original hyperbola. So you've got an asymptote at the y-axis, asymptote at the x-axis, and so asymptotes are at, I don't know why I started with y, but y equals 0, x equals 0. Line of symmetry on this one doesn't have the diagonal lines of symmetry like the last one did. This one's just got that line of symmetry straight up and down the center. Okay, so your line of symmetry is here. Okay, and so again, that line is just x equals 0. Domain. So this graph also, like the one we looked at before, goes forever left and right, but it doesn't hit this one value in the middle of 0. Okay, so domain is all reals except 0. Range is a little bit different though, because now this doesn't get into negative territory for the y values at all. So I'm just going to say all reals greater than 0, all the reals that are above 0. And do notice that I didn't include 0 because 0 is an asymptote here. Okay, so give a new equation with this transformation, 3 to the left and 4 down. And so I'm going to write my rule. 3 to the left would be x minus 3. 4 down would be y minus 4. Okay, and so in my equation, I'm going to end up with, and I'll do kind of my rough draft down here, I'm going to have y plus 4 over here, and then 1 over, and with the x, we want to do an x plus 3, with the square on the outside. Okay, so that plus 3 is directly attached to the x. Before it gets squared, before anything else happens to it, we want that plus 3 in there. And so the only other thing I might do is shift this 4 over to the other side. So I'm going to write this as y equals 1 over x plus 3 squared with a minus 4 hanging out here. Okay, but again, if you did this on your test, that would be perfectly fine with me. Okay, so now graph the new function. Here's what I think is the easiest thing to do with a question like this, is I'm going to take where those asymptotes are located, which is basically the x and y axis, and I'm going to shift those according to this rule. So I'm going to shift backwards by 3, to the left 3, and down 4. And that's kind of my new center, right? Really what I did there is I translated the origin. And now this is going to be my new x-axis, quote unquote. This is going to be my new pretend y-axis. And then I'm just going to sketch my graph in according to where those asymptotes are. So now I know my graph is going to do something like this. And I know it looks like it got bigger. It didn't really get bigger. Now you're just seeing more of it, right? Because we shifted it down, so it looks like there's more of it. Okay? We know that that graph is infinite, but there in purple, hopefully, you can see what that new function would look like once you shifted it. Just trying to darken it in so you can see on the answer key. There we go. Good enough. Okay. Let's see, does this keep going? Yep, I thought so. So give the equations for the new asymptote. So I'm going to do this. I'm going to put this here. Okay. Our asymptotes used to be at x equals 0 and y equals 0. Shift that up so you can see it. Those are now going to shift according to my rule. Lay those side by side. There we go. So my new y asymptote is now going to be y equals -4. And that happens to be this line right here. This line down here is y equals -4. Okay? And then my x asymptote is going to move 3 to the left, so it's going to go from 0 back to -3. So now I have an asymptote at x equals -3. Okay? And that's this guy here. That's x equals -3. Next question wants to know new lines of symmetry. So my line of symmetry used to be that same x equals 0 line. Now it's going to be at x equals -3. Okay, again, this vertical line right here, that's my line of symmetry. Okay, new domain and range. So my domain, again, I've got an asymptote at x equals -3, meaning that I can never let x be -3 here. So I would now say my domain is all reals except -3. And again, you can think of it just like, hey, I took that 0 and translated it according to this rule. Okay. And then for range, same thing. We used to have to stay above 0. Move that out of the way. We used to have to stay above 0. That shifted down by 4. So now we have to stay above -4. So all real numbers greater than -4. Okay. I think I'm going to cut this video here and just start a second video. That way you're not stuck watching one giant long video. So what's this one covered questions 1, 2, and 3, which were actually really long. And then I'll do a second video that goes 4 through 9. Okay. So stay tuned for that.